Welcome to Chapter 2, where we dive into the role of discrete math in software testing. In this chapter, we explore how discrete math tools enhance testing precision and reliability, starting with set theory. Sets allow us to group elements, like test cases, in structured ways. We define sets and use membership symbols to indicate inclusion or exclusion within a set. These foundations are crucial for organizing testing data. Next, we cover set operations such as union, intersection, and complement, which let us analyze relationships between sets of test cases. For instance, the union of sets can represent all possible test cases, while intersections highlight overlapping test conditions. This is a practical approach for testers managing complex data relationships. Moving forward, Venn diagrams come into play. These diagrams visually illustrate set relationships, making it easier to identify missing or overlapping test cases. As testers, using Venn diagrams helps us communicate clearly and ensure that we've mapped all test scenarios effectively. Then, we introduce functions, mathematical mappings between inputs and outputs, essential for programs like the nextState function. Functions help testers define what each input should produce as output, supporting rigorous test case creation. Set relations come next, covering concepts like one-to-many and many-to-many mappings. These are especially relevant in data modeling, where relationships between different data points need to be verified. Understanding these relations helps testers simulate real-world scenarios accurately. We also discuss set partitions, dividing a set into distinct, non-overlapping subsets. In testing, partitions let us separate data into meaningful groups, ensuring comprehensive coverage and preventing redundant tests. Finally, we touch on propositional logic, a system that allows us to frame test conditions as statements that are either true or false. This logic is foundational for creating reliable, precise testing frameworks. It helps us set up logical conditions and check for all possible outcomes.